This is AP Calculus B, AB, B, Section B, Unit 5, Lesson 4, Areas in the Plane 2. I got a little ahead of myself in the last video by including differentiating on y, because that's actually part of this lesson. So I thought I'd just give another example where we find the area between two curves using both the integration on x and integration on y, right? And so here's the problem I propose. I propose finding the area between these two curves. Y equals 2 to the x, the power function, and y equals x squared, a quadratic function. Okay, and the interaction between these two is kind of interesting. They actually intersect 3 times. Y equals 2 to the x, and y equals x squared. X squared. Okay, they intersect 3 times. Once here, and once here. Okay. And if I want to find the total area between them, I can break it down into 2 integrals. I'm not going to do so. I'm going to concentrate on these 2 intercepts, 2, 4, and 4, 16. And I want to find the area between those. Okay. I'll leave the other part for you to solve on your own. Okay. So let's grab a screenshot here. Okay, screenshot. And like that. Okay. And so there's 2 ways to look at this thing. One is to look at it as slicing it into vertical rectangles. So I'd like to take a rectangle right here, where the width of the rectangle is just delta x. It's my change in x, right? It's a little tiny thin slice, okay? But what is the height of my rectangle? Well, the height of the rectangle is the red curve minus the black curve, right? In this case, y equals x squared, and y equals 2 to the x. So this is going to be, h is x squared minus 2 to the x. Okay? X squared minus 2 to the x. And so the area of the rectangle, is height times width, or width times height. Or we could say x squared minus 2 to the x, delta x. Okay? And automatically you should recognize, hey, this is a Riemann sum in which the width, we're going to take the limit as the width of the rectangles goes down to 0. The number of rectangles goes to infinity. We're going to take the sum of all of them, right? And that is the very definition of an integral. So the total area is going to be the integral from this intersection point to this intersection point, 4. So from 2 to 4, the integral from 2 to 4 of x squared minus 2 to the x dx, replacing delta x with dx with the differential. Okay. Right. So that really is the trick, and this is the crux of the lesson. Can you set up this integral? Can you find the integral? That's another matter. That's what we've been practicing and working with for the last month or so. But we will certainly do that. But can you write the integral? Right, so let's go ahead and do so. Let's go ahead and finish it. All right, let's see. The integral of x squared is 1/3 x cubed. The integral of 2 to the x, I know the derivative of 2 to the x, it's 2 to the x ln 2. So the integral of 2 to the x must be 2 to the x divided by ln 2. 2 to the x divided by ln 2. Okay, from 2 to 4. Okay. All right, so let's do this. 1/3 times 4 cubed minus 2 to the 4th divided by ln 2 minus 1/3 of 2 cubed minus minus or plus 2 to the 2nd over ln 2. And we can simplify this. 4 to the 3rd is 64. No, 4 times 4, 16. 16 times 4, yeah, 64. 64 thirds. Minus 2 to the 4th is 16 over ln 2. Minus 2 to the 3rd is 8, so 8 thirds. 2 squared is 4 over ln 2. We have some like terms. 64 thirds minus 8 thirds is 56 thirds. 16 ln 2, negative 16 ln 2, and 4 ln 2 leaves negative 12 over ln 2. Okay, and let's go ahead and see what that comes to. That's about as simple as that gets. Okay, so we said 56 thirds minus 12 over ln 2. Yep, there we go. 1.354, approximately. 1.354. Okay, so that's the approximate area. By the way, you should be able to estimate the area. 1 square unit is right here. And so as an estimate, as a general estimate, this is 1 point, so this is the area, total area of this whole thing. And actually, no, that's not right, because 1 unit going sideways is not 1 unit going up. So this point is 4, and so 1 square unit is like this. There we go. 1 square unit, 1 wide by 1 tall. Okay, and this is 1.3 of those. That seems reasonable. Okay. All right, so let's now break this down into a horizontal slices instead of vertical slices. Okay, so as such here, we're going to slice it like this. So we're going to have delta y. And what is the width, or yeah, we'll call it the width of our rectangle. What is the width of our rectangle? Well, we need to solve these for x. So y equals 2 to the x. Ln y equals x ln 2. X equals ln y divided by ln 2. Okay, so that's the top one here. Okay, and y to the x, y equals x squared, solve for x is x equals root y. Plus or minus, but we're on the positive side. So, all right. And which one is which? The red was x squared. So the red is x equals y, root y. So the width is going to be ln y over ln 2 minus root y. Okay, minus root y. So there's my width. So the area of the rectangle is length times width, ln y over ln 2 minus root y, times the height of my triangle or rectangle, delta y. So the area becomes the integral from what to what? Well, this is 4 on the y-axis, and this is 16 on the y-axis. So from 4 to 16, the integral of ln y over ln 2 minus square root y dy. Okay. All right. So let's now evaluate the integral. Okay. The integral of ln x. I'm not sure that's something we've covered because deriving it requires partial derivatives. integration by parts. So the integral of ln x dx, I'll just give it to you, is x ln x minus x. X ln x minus x. Okay? So the integral of ln y is y ln y minus y, and then all over ln 2. The integral of y to the 1/2 is increase the exponent by 1. That makes 3/2. Divide by that, so multiply by 2/3. Y to the 3/2, so y cubed square root. That's 3/2. Okay, and evaluate that from 4 to 16. Okay, so 16 ln 16 minus 16 over ln 2 minus 2/3. Square root 16 is 4. 4 to the 3rd is 64. Minus, now insert 4. 4 ln 4 minus 4 over ln 2. Plus, because it's minus and negative, 2/3. Square root of 4 is 2. 2 to the 3rd is 8. Okay, I can simplify it more, but I'm just going to cut to the chase and see if I can figure out what the area is. Okay. So let's see. 16 ln 16 minus 16 all over ln 2 minus 2/3 times 64 minus 4 ln 4 minus 4 over ln 2 plus 2/3 times 8. And look at that, the same answer, 1.354. Okay, all right. Now you should also, you'll be given some problems where you can't find the integral using conventional methods, and you need to find the integral using your calculator, and that's perfectly fine. In fact, let me verify these. Okay, the integral, okay, let's do the first one. The integral from 2 to 4 of x squared minus 2 to the x dx, 1.354. Okay, and the integral from 4 to 16 of ln y divided by ln 2 minus square root y dy, negative 1.354. Okay, so use your numerical integration on your TI-84. In Desmos here, you just type int to do a definite integral, right? And you can verify, and sometimes that's the only method a numerical solution can be found. All right, so hopefully that helps. Lots of fun, lots of conceptual stuff.